In the last video, we looked at conversions using Avogadro's number. In this video, we're going to look and see if we can't figure out if there's any good conversions we can do within a molecule. And so let's start out with an example of 1 mole of sulfuric acid. If you have 1 mole of sulfuric acid, you may be interested in finding out how many moles do I have therefore of oxygen. What you're going to do with these types of conversions is you're going to use the numbers that are within the molecule, within the chemical formula. What I mean by that is for every 1 mole of sulfuric acid, there's 2 moles of hydrogen atoms, 1 mole of sulfur atoms, and 4 moles of oxygen atoms. Just because there's 4 for every molecule. There's 1 for every molecule, 2 for every molecule. And so when we're looking at these types of questions of if you have this many moles, how many moles do you have of something within it, you can use these subscripts simply to convert within a molecule. So to convert this one to oxygen, we know that for every 1 mole of sulfuric acid, there is 4 moles of oxygen atoms. And so that would give us a total of 4 moles of oxygen. You could say oxygen atoms if you wanted to, whichever you want to do, but you do need a number and a unit. So that's one example. Let's do a couple more. Let's say we start out with 17.2 moles of sulfuric acid. And I want to know how many moles of hydrogen do I have within this. Same principles apply. Every 1 mole of sulfuric lends us to 2 moles of hydrogen. Multiply 17.2 times 2 is going to give us 34.4, keeping our sig figs straight, moles of hydrogen. Let's do another example. If you have 0.54 moles of calcium carbonate, CaCO3, how many moles of oxygen do I have? Same principles apply. We've got, for every 1 mole of calcium carbonate, we have 3 moles of oxygen. And that gives us a total of 1.62 moles of oxygen. And this is where it kind of gets interesting. What if I were to then say, all right, we now know how many moles of oxygen we have. How many atoms of oxygen do I have? Not moles of atoms, but just straight up atoms. We can go back and think through the same types of conversions we did in our previous formula to convert through and figure out how many atoms we have. I could have just started the problem with, if you have 0.54 moles of calcium carbonate, how many atoms of oxygen do you have? You would have had to have converted to moles of oxygen first, and then done another conversion factor where you take your 1.62 moles of oxygen and you convert that to atoms of oxygen. So remember how we did that. Any 1 mole equals 6.022 times 10 to the 23rd. And I'm going to say atoms of O, and these are moles of oxygen, atoms, so you could put that there if you wanted. Moles are going to cancel, and you're going to be left with atoms of oxygen. So 1.62 times 6.022 times 10 to the 23rd yields 9.76 times 10 to the 23rd atoms of oxygen. And so using these types of conversions, you can go from mole to moles of something within that same compound, or moles all the way to atoms, or you could even go in the other direction to get you to molecules. It depends on what the question's asking as to how you're going to set up your formula. But do note that these subscripts go with the element that you're looking for. So the 2 with the H, the 4 with the oxygen, and so on and so forth.